Hey class, it's Professor Rourke. I wanted to make a little video regarding one of the questions on partial fractions because it starts out one of the first problems in Webassign, and I think it just sort of throwing people off because we didn't see every type of like problem the other day in class, and so I figured this would be helpful because I've had a few different questions about it. So this is question number 1 from the 7.4 homework. And all you need to do in this first part is just write out the form of the partial fraction decomposition of the function as seen in, quote, this example. And then they have this example you can put that shows how they took the original expression, which was x cubed plus x squared plus 1 in the numerator, divided by x times x minus 1 times x squared plus 1 times x squared plus 1 to the third, which is fine to show us that example, but it's not really the most helpful, I'd say, because it doesn't really show you how to do it. It just, I think, is explaining how they want you to write the answer more than actually explaining the process. Okay, so I left up on here the answer key for you to see for numbers number 1, part A and B. The problem, I think, mostly has been part B, but let's just kind of talk through part A real quick, and then we'll get into how we are going to solve for B, part B. Okay, so for part A, we have x to the 5th plus 9 in the numerator, which technically, we talked about this a little bit the other day, that means there's a degree of 5, okay, in the numerator. And then in the denominator, let's think about this. This is actually like the degree of 6. Hopefully this makes sense, because if we were to essentially like expand this fully out, the highest exponent we would get from multiplying everything together is x to the 6th. Okay, so this would be what we would call a proper fraction, okay, where from here we just go ahead and start seeing how we can factor anything else that needs to be factored, in which case you can sort of see from the answer key, we would be able to factor x squared minus x into 2 linear factors. Okay, this is important. These are 2 linear factors. X and x minus 1 are both just linear factors. So that's why they have like just a constant a. They chose a and b to a to be above x and b to be above x minus 1. However, x to the 4th plus 6x squared plus 9 actually factors further into x squared plus 3 times x squared plus 3. So when we have something like x squared plus 3 squared as a factor in our original expression, that means this is a repeating like quadratic term. So what that means is that whenever it's a quadratic term, it gets like 2 letters. It gets the x squared plus 3 gets cx plus d, and then the repeated part of that, which was x squared plus 3 quantity squared, gets ex plus f. Okay, so I know, again, that one could have posed some problems in some regards because people, I think, needed to kind of get comfortable with the whole, which is it? Is it a linear term or is it a quadratic term? And is it repeating? Okay, because all of those tie into whether or not we use just one constant like a, or we have to use 2 constants like ax plus b, and all that stuff. Okay, so I hope that makes sense. That is just a matter of understanding what the different cases are that we have. The next problem, though, I think is where we saw a little bit of issue, because if you actually pause to take a look at this, we have x squared, and we have, so it's like a degree of 2 in the numerator, and a degree of 2 in the denominator. Okay, so this is not technically what we would say, like I wouldn't naturally call this an improper fraction, but you kind of think about it in my mind. Okay, if I don't know, back in our normal number world, if we had something like, for instance, 4/4, we could simplify this just to be 1. Okay, usually we sort of reserve the words improper and proper in terms of numbers, let's say like 1/4, that would be what we would call a proper fraction. And then like 5/4 would be something we would call improper. But 4/4 isn't usually something that we would be like, oh, that's proper, that's improper. So I can see why this one could have caused a little bit of confusion because the degree is the same. Okay, but if the degree is the same, we do still want to use polynomial division first, and then we want to go into partial fractions. Okay, so again, this is because the degrees are even. They're the same, I should say. The degrees are the same. So if the degrees are the same on the numerator denominator, or, if the degree on the top is bigger, if it's definitely clearly an improper fraction, then we would also need to do that. Okay, we'd need to use long division. So I'm going to go ahead and get started just to kind of show you how this is going to look. We don't go very far. You'll see. Okay, so I just have x squared divided by x squared plus x minus 12. So first things first, it's like, okay, what times x squared gives me x squared? You're like, oh, 1. Okay. So 1 times x squared is x squared. 1 times x is x, and 1 times -12 is -12. You're like, okay. But then I need to subtract these terms away. Okay, so again, throwing it back to some long division that we haven't seen in quite some time. So I like to go ahead and change all my signs. There's a few different ways to do it. You could also put parentheses and like distribute the negative into the other terms. It's kind of up to you. The big idea is though that whenever we're doing long division in this step, we subtract, and we have multiple terms here. So that's where it gets a little tricky. Okay, so x squared take away x squared, that's 0. And then we have 0x minus x, which is -x, and then we have like 0 plus 12. So what it actually comes down to is like -x plus 12. Okay, and then we cannot further divide this, right? Well, now we're looking to see like, okay, I have -x, -x divided by x squared. That doesn't work. Like what times x squared gives me -x? No. So when that happens, we're essentially like done, and we now just have a remainder of -x plus 12 divided by x squared plus x minus 12. So the reason I think a lot of us weren't really getting these problems is because we weren't uh, thinking about it as having to divide first. Okay, so once we do that, then we'll be like, okay, so the one's chilling, the one's hanging out. X squared plus x minus 12, that factors into x plus 4 times x minus 3. So if I wanted to try to rewrite 1 plus -x plus 12 divided by x squared plus x minus 12, I would want to split this up into, these are two different linear terms. So it's like a plus x over 4 plus b times x minus 3. Okay, so I hope that was helpful. Again, this was 1B from the Webassign work. And I think, again, part of the problem was just looking at it, we might not have originally realized that we would need to do polynomial division before we went right to partial fractions. So a lot of us might have just put like gotten this part, the a divided by x minus 3 plus b divided by x plus 4, but didn't really understand why the 1 was there. And the 1 just happens to come out because that's what we have to do when we have the same degree, right? Just like we have to do when there's like definitely an improper fraction. Okay, so just kind of looking through most of the problems on Webassign just to kind of give you an idea. Number 2 is proper, so we don't need to worry about long division, okay? Because the degree is 2, I don't even have an x in the numerator. Same thing for 3, okay? Won't need to really worry about any possible polynomial long division. However, 4 is one that I see that looks like it could be a candidate for some polynomial long division because it's x squared in the numerator and x minus 4 in the denominator. Okay, 5 looks proper. So I don't think I'm going to need to bust out any long division there. 6 looks proper. 7 looks proper. 8 is proper, even though it's funky. And 9 has the same degree. So for 9 is another one where we will want to first check to use long division to be able to rewrite it. And then we can go from there. Okay, so I hope that was helpful in some regards, but please keep me posted, and I will see you all soon.